Maganda umaga, or good morning. Welcome back to the Philippines. This video is going to be a bit of a detour as I got a couple of requests for manual RAID creation. So we'll be doing that on a Debian 12 install. But before we jump to that, another bit of unfinished business. I also got a couple requests because in a few videos ago I talked about my street dogs. So they're there, right there. There they are. Okay, that's dos and tres, or dos and tres. We originally had uno, dos, tres, and cuatro, which to me sounded better than Isa, Dalawa, Tetlo, and Alpat. But yeah, uno and cuatro didn't make it through the first year, but that's pretty common with street dogs. These two, they're probably going to live for quite a while. So, but yeah, they're my street dogs. We raised them since they were pups. They're about a year and a half, almost 2 years old now. So whatever breeds, not even sure because they're a mix. Anyway, on to the video. Alright, since I did my video on using graphical web GUI called Cockpit to set up a RAID on a Debian installation, I've gotten several requests to know how to do it manually. So that's what we're going to cover in this video, is setting up a manual RAID using command line. It'll be in Debian 12 because that's what I'm using on my servers right now. And before jumping into that, I want to go through a bit of an introduction about RAID and what it is for the various people who haven't dealt with it before. So if you're fairly conversant with RAID, then you can probably skip ahead about 2/3 of the way through the video. The time link should be down in the description someplace. So unless you're really fascinated about learning about RAID, you can jump ahead about 2/3. So let me get on with the explanation of RAID, and then we'll move on from there, okay? All right, let's dive right in with an overview of the what actually RAID is on a computer. So again, skip ahead about 2/3 mark. If this is redundant, links below. Otherwise, follow along. So let's talk about a few terms we use when we're discussing computer RAID arrays. We'll talk about common types of RAID arrays. A nested RAID array, that's where we take one type of array and nest it in another RAID. And there are reasons for doing this. Then we want to talk about hardware versus software RAID. And then we get on to our actual fun stuff, setting up a RAID5 array from the terminal. We'll discuss sudo versus su versus root, because you do need administrative permission to do this. Mount points and names, you're going to need both, so you need to think about those before we actually get started. Yeah, how to check our storage drives, make sure they're set up properly. If you throw a drive in there, it's got partitions, it's not going to work, but we'll talk about that. Then the actual creating of the RAID array. The formatting of the RAID array, because once you create it, you're not finished. And then mounting the RAID array, again, still not finished. See, a lot of this stuff is handled automatically by your web GUIs. And finally, make the array permanent by setting it up to survive reboot. It involves the fs tab file, md admin config we'll talk about, and resetting up the init RAM fs drive. So let's get to it. So the first term itself is RAID. It's an acronym for Redundant Array of Inexpensive Disks. It's a way of combining multiple disks into a storage unit or storage volume, and it also involves some methodology for adding some fault tolerance, so that if you've got a multi-volume disk set and a disk fails, you don't lose all your data. Then we'll talk, RAID level. Level is, well, I never really liked the term RAID level. It's the type of RAID array. It's not really a level. You'll see that when we get into talking about the different types, but it's not really a level. There's a couple of processes we use in making arrays, RAID arrays. One of them is called striping, which is where we divide the data between the multiple drives. The big reason for doing this, besides making a bigger volume, is when we're using multiple drives, you're not restricted strictly to the read-write speed of one drive, but you can actually, while writing data to one drive, start writing it to another. It gives you this little faster input-output. Parity is another term we use when we're talking about RAID. It's the fault tolerance I was talking about earlier, or a way to ensure data integrity. There's a couple of different methods for doing this. As far as parity goes, the first method there is a parity drive, which is a drive in your array strictly using for parity data. And what you do with parity data is if you lose a data drive, you can replace that data drive, and with the data on the other two drives in your parity data, you can reconstruct the data drive. Do be advised, this is a very time-consuming process to do, though. Usually backups are a lot faster than, well, yeah, we'll talk about that. Then there's stripe parity, where instead of having a single dedicated parity disk, you can stripe your data across the disks along with your parity information also. And then again, same effect. If you lose a disk, you can recover that disk by inserting a new one with using both the parity data and the existing remaining data. We're not going to get too heavy into how parity works. It's complicated. Well, it's not complicated. There's a lot of math involved, and a lot of people find these type of discussions kind of boring. They're interesting at a certain level, but we carry on too long. Something called resolver, which I always refer to as resyncing, is an array recovering and restoring data from a bad drive. And we'll talk a little bit about the time involved to create an array and restore an array, because that's something a lot of the tutorials seem to miss out on, is that it's not quick. I mean, if you got small drives, in the case, for example, we're using very small drives, so it's very quick. But if you're using terabyte or bigger, you're talking hours, even a day. It could take some time. Just be aware of that. There's another term called scrubbing you're going to hear periodically. Scrubbing is checking your array data for consistency and integrity. Mirroring is another RAID methodology like parity. It's where you make identical copy on a second disk, and you do it on the fly so that if one disk dies, you can continue on with the second disk. And again, it's easier to understand how it reconstructs data. When you slap a new disk into the array, it just copies from the old disk. But again, it increases your redundancy and your fail-safe by having identical copy of your data on a second disk. There are some downsides in the amount of storage you actually get when you set up a RAID array, but yeah. Then there's such thing as hardware RAID, which is actually hardware and firmware used specifically to create and maintain a RAID array. You have a specific card in your computer or specific hardware and firmware that does this, as opposed to the software RAID, which is strictly software based, which is what we're going to be dealing with today. And then there's another term you'll hear, it's called degraded. An array with a bad drive, a drive that's failed, is considered a degraded array. In a lot of cases, the array can still function when it's degraded, but it's best if you get that drive replaced and let it repair itself. All right, moving on. So our first topic we're going to tackle is the stripe volume. This is a RAID 0 type array, and in a RAID 0 you need 2 or more drives, and the data is striped across the drives. It's broken into chunks and they're written to the different drives. It's distributed or striped across the drives. One quick thing I want to note here is a lot of times people say you need the same size drives for RAIDs. This isn't exactly true. It's good to use the same size drives because your storage is based on the smallest drive. For example, if you have a 500 gigabyte and two 1 terabyte drives. You don't have 2.5 terabytes. You've got 1.5 terabytes because you're only going to use 500 gigabytes because that's your off the 1 terabyte drives because that's your smallest drive. So that's why they tend to make RAID drives the same size. More space efficiency, I guess, is a good way to put it. There is no fault tolerance in a RAID 0. Your data is neither parity or mirrored. You lose one drive, the whole array is gone. So you might be asking, why would people use this kind of setup? Well, the biggest thing for RAID 0 is if you need to create a very large volume with improved performance. Again, we talked about writing data to multiple drives is faster than writing it to one drive. Like I say, you're using this for an application where performance is the primary concern above reliability or data recovery. That would be the reason to use a RAID 0. Next up on our hit parade is mirrored data or RAID 1. And in this situation, you're creating two identical copies of each block of data and you're writing one to each hard drive. So like in our example, S1A is an exact copy of S1B, it's just on a different hard drive. So you need two drives, you write data twice, once to each drive. So storage capacity is going to be based on the single smallest drive, and this is basically two drives, period. You've got 50% of space because one is lost to mirror or identical copy of your data, so not what I call super efficient storage-wise, but it's very good for recovery. So high level fault tolerance is one drive can totally fail and you still have all your data and the array still operates. However, this comes with a downside. There will be some possible performance or degradation. A lot of people will tell you that this is handled by the RAID software and its buffers, but again, under high stress situations where you're moving lots of things around, doing lots of computations, you will notice a difference using RAID 1. It will be slightly slower writing to the disks. The more you're pushing your computer, the more slower it's going to be. If you're doing simple word processing, you're probably not going to notice. All right, up next we have striped with a parity drive. RAID 4. You're probably not going to see this out there too much. I have never actually seen one other than when I made one. And in RAID 4, we have a minimum of 3 drives, and then we have one of them's a parity drive plus in data drives. So for example, if you have 3 drives, you have 1 parity drive and 2 data drives. If you have 4 drives, you have 1 parity drive and 3 data drives. Your storage percentage increases the more drives you have installed. So again, storage capacity is based on data drives only, and like most other RAID configurations, it's going to be based on the smallest drive times the number of drives. There's a fault tolerance here as one drive can fail and the array still operates. In the RAID array configuration, to pull the data off and you can replace the drive, it will rebuild itself. Again, it takes time. You're going to have a performance hit when this happens. Another advantage of RAID 4 is it's easy to extend if you zero out a drive, and that basically means writing zeros to every block on the drive. Then you just add it in and you extend out your number of data drives, and it'll automatically pull the drive in, but you got to zero the drive first. It's got good read performance, again reading from multiple disks, low write performance because you're doing parity checks and parity writes. Otherwise it's okay. So next on our hit parade here is striped with striped parity, which is RAID 5, which is the one I'm going to be using today. Again, the data is striped across the drives and the parity is striped across the drives. Minimum of 3 drives. You can have any number of drives beyond 3, but minimum of 3. And again, calculated from the smallest drive. Don't actually lose a drive to parity, but you lose the equivalent storage of that drive to your parity bits. So yeah, you lose a drive, even though it's not a specific drive, and the loss is spread out across all drives in the array. Same fault tolerance as with a parity drive itself, in that if one drive fails, you can rebuild, even though it takes some time. It's got good read-write performance in most cases. There is one particular case where read-write performance is going to suck on this type of array. This is the write amplification. This happens when an already writ sector means you got your data and you got your parity already written, and it changes. You need to rewrite the sector, maybe into two sectors. You need to rewrite your parity bit to update it, and that will ding your performance when that happens. Otherwise, it's got good read-write performance. All right, our next subject, stripe data parity, double parity. So this is RAID 6, and it differs from RAID 5 in that you've got two sets of parity data written across your drives. So we've got, for example, A1, A2 data has got A parity bit 1 and A parity bit 2, and so on, but it's double the parity, so you lose twice as much storage as with single parity. However, well, first you need a minimum of 4 drives to make this happen. And with a double parity, you can technically lose 2 drives. Again, the more drives you have, the better storage ratio. You can technically lose 2 drives from your array and it will still operate even though it's in degraded mode. Again, you're losing storage. With a 4-drive array, you're back to mirrored type storage, but if you add more drives, your storage percentage increases. It's got good read performance and then poor write performance because, again, you're writing a data sector, then you're writing 2 parity sectors. Next, we come to a type of nested array. This is often referred to as RAID 10 or RAID 1 plus 0. In this case, we have 2 mirrored arrays, RAID 1, and then these are combined into a striped array, RAID 0. So you can lose a drive from each mirrored pair and this will still function. There are also different types of nested setups, but this one requires a minimum of 4 drives. Okay, before we get into actually doing an example, let's talk about the hardware versus software. So with a hardware RAID, you get better performance because stuff running at a hardware firmware level tends to be faster than stuff running at a software level. You get reduced complexity. A lot of the setup is handled by the hardware itself. It exists at boot time because your computer detects the hardware and boots up the array. There are some downsides, however. Generally, from what I've seen, your hardware arrays are vendor-specific hardware and software, and you're not going to be changing them once you're using. You're stuck. You're sort of locked in there. Plus, there's the cost of the hardware as opposed to a software array. You need a set of hardware, you need an extra card or some extra components in your computer to make this work. So yeah, you've also got the cost of hardware that is sort of a negative for hardware arrays. On the other hand, software RAID arrays, open source, flexible are the 2 big advantages to software RAID arrays. The disadvantages are overhead. Again, they're more code, more stuff going on because you've got to make up for that missing hardware functionality in your software. So you have more overhead, and then actually they're tied to a specific OS. Windows does it different than Linux, which does it different than Unix. So, if you're using Unix, if you're using Linux, you've got a lot of different distro choices, but it's still going to be Linux. So you are limited to a specific OS with the software. Okay, let's get to what everybody's here for, actually creating a RAID 5 on the command line using Debian 12. So we need to log in, and as you can see here, we are using Debian 12. Here's our neofetch output. Not that you really need to see that, but yeah, that shows you kernel, packages, all the stuff about our install. Interesting resolution, 1024 by 768. I'll have to check into that. Technically, I thought it should have been 1080 or 1920 by 1080, but well, I think I messed around with the size so you could read it better. So if we do an ls block, we can see that I've got my SDA as my root directory, SDA2, and then I've got SDB, SDC, SDD, and SDE as my available drives. So there's 4 drives there. They're not very big. Like I said, they're only 32 gigs, so this is going to be quick. If you have 1 terabyte or bigger drives, this is going to take some time. DF-H to see our space allocations. I always use the H option for human readable. We can look in a file called, in the proc directory called mdstat, and we can see that there is no RAID array of any sort running. And let's take a look at the high level here. So a lot of people put their RAID arrays in the mount folder. I usually use mount for other things, so I usually put them in the service folder or SRV folder. So that's where I'm going to be putting it. So we're going to make a directory in the SRV folder, and it's called RD5 for RAID5, and then _0 for the first one. And I will need my password, since a lot of stuff involved in making a RAID array, it need to be administrator, so you either need to be root, you need to use sudo, or you need to use su to become root while you're doing this. Again, not here to argue the security or usefulness of any particular method. You just need to be root. Now we'll actually set up the RAID array. So we're going to use sudo md adm for admin, create, and then our mount point is going to be md0. Remember I said you need to think of a mount point. md0 is pretty much a standard across most of the Linux distributions for what you call the RAID array in your devs directory. Our level is going to be RAID5. We have 4 RAID devices. So you can list them all out individually here. Take up some line space, a lot of typing. However, there is a shortcut you can use. With a square bracket B-E in square bracket, that'll hit every dev SD in the directory. See, that's just a shortcut for writing everything out. It'll expand to the same thing. And as I said, they're small, so this is going to be quick. We've created our RAID array, and we can now see if we use ls block that every one of our drives now has an MD0, and the MD0 has a size of 95.9 gigs. So we had 4 32 gig drives, which should have been 120, but we lose a drive to parity. So yeah, 95, 96. There'll be some overhead in there, so the actual size will be somewhat smaller when we finish up here, but yeah, it's going to be the 90s, 94, 95, 96, somewhere around there. So once we've created it, we've got to format it. We'll use the sudo makefs, and we'll use our ext4 file system. Again, not large, so it won't take long. Then we want to mount the drive. And remember I talked about the directory we made earlier. So we mount dev md0 to srv rd5 _0. And then if we do we can do an ls block again. Nothing should have changed other than we have mount points now for each of the drives. But if we look at df-h, you can now see that we have a 94 gig drive with 90 gigs available, mounted to serve to our mount point for our RAID array. So yeah, we've created it. Now the next trick is to make this permanent. To do that, first thing we need to do is modify our fstab file. Again, it's going to be dev md0, and then our mount point srv /rd50. ext4 is our file system, and we use defaults, no fail, and discard. That should be pretty standard for this type of RAID array. And then 0 and 0, and then save. Once we reboot, FS tabs will mount this automatically. You can do a cat to make sure you've got it in there. One thing about FS tabs, you need to use tabs and not spaces to separate your information. But that's just our first step. So if we look in this file, which was created when we loaded the MD-ADM software package, we've got some text, we've got a few lines, but there's no RAID array here. It has to be listed here also, as well as in FS tabs, because this is what actually puts it together. Luckily, in this case, there's an easy way to do this. We go MD-ADM details, scan. Details will tell us the information we need to place in the file. Scan will scan for array instead of actually entering it. We know we've only got one, so we can get away with this. Then we'll T this because we need to use sudo. This is a administrative file to write it to, or etc mdadm mdadm.config file. And that's done. And we can look at it and we can see what we actually wrote there. The array name and the UUID. And finally, to get this thing up and running at boot time, we need to modify our init ram fs, or file system. So sudo update init ram fs tac u, which will replace our existing file system. Once that finishes, we can go ahead and reboot. And we log back in. Everything looks good with ls block. And our RAID array is still present. Yes, there it is. So we've created the array, we've mounted the array, and we set it up to survive reboot. So I think we're there and we're done. Now that wasn't so hard, was it? Okay, that should about wrap things up for this session. We talked about what RAID is, and we talked about setting up a manual RAID, and it's not that hard. I mean, it's a little more, well, there's more steps in doing it through the command line, and it might not be as obvious, but again, it's not that hard, so I'm hoping you can give it a try sometime and see how it works. I always think about sometimes getting rid of these GUIs that I use and going strictly command line. GUIs are convenient, but they don't always work the way you expect them to work, and they don't always do what you want, or at least what I want. So anyway, don't forget to, what is it? What's supposed to say? Oh, like, subscribe, comment, yeah. And I do try and answer all the comments I get, even though it's not that many, so it's not that hard, but it's something I enjoy doing. Actually, I get more responses through messages, like I actually got one in LinkedIn. And anyway, that's it for now. We'll see you next time around, where I'll get back. I promise next time around I'll get back to my Proxmox series by doing an overview of the interface for Proxmox. So we'll see you then.